Welcome back to Arxflix. Today, we're breaking down a critical paper titled, Poisoning Web-Scale Training Datasets is Practical. This paper introduces two alarming dataset poisoning attacks that could potentially compromise the training data of large deep learning models. Let's dive in. Modern deep learning models rely heavily on massive datasets crawled from the internet. Due to the sheer size of these datasets, manual curation is virtually impossible. This offers an opportunity for adversaries to introduce malicious samples into datasets, called poisoning attacks, which can lead to targeted mistakes in model behavior. The paper introduces two novel and practical poisoning attacks: split-value poisoning and front-running poisoning. Split-value poisoning exploits the mutable nature of internet content. Here, an attacker ensures that the dataset seen by the curator is different from what a client later downloads. This attack leverages the lack of cryptographic integrity checks. For instance, expired domain names can be bought and malicious content can be uploaded, which will be included in future dataset downloads. For front-running poisoning, the attack targets web-scale datasets that take periodic snapshots of crowdsourced content, like Wikipedia. By timing malicious edits just before a snapshot, adversaries can ensure poisoned content is included in the snapshot, even if it gets reverted later. This graph illustrates how edits made close to the snapshot time can be included in the poisoned dataset. The paper demonstrates that these attacks are shockingly cheap. For just $60, they managed to poison 0.01% of large datasets like LN0M and COO70M. So, how can we defend against these attacks? The paper proposes two defenses. This defense involves distributing cryptographic hashes for all indexed content. This ensures that clients receive the same data as when the maintainers first indexed it. The hash function h=h(xi) can prevent split-value poisoning by invalidating any mismatched content. For front-running poisoning, defenses include randomizing snapshot orders or delaying content inclusion until it's been reviewed by trusted moderators. However, these defenses are not foolproof. For instance, integrity checks may flag benign modifications, and timing-based defenses assume the existence of a trusted curator, which might not be practical for all datasets. In conclusion, this paper sheds light on the vulnerabilities of web-scale datasets and the practicality of poisoning attacks. It's clear that more robust and innovative solutions are needed to protect our machine learning models. That's it for today's video. If you found this overview interesting, don't forget to like, share, and subscribe for more deep dives into cutting-edge research. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.